Hello everyone, my name is Ankit Nanwal and today we will be starting with the new topic that is moment of force. So what is moment of a force? So basically it is the turning tendency of force about the point where we want to generate the moment. Okay, so you all have must seen the door in which it is hinges at one end and it is free at the other end. So when we apply a force at this point, so it rotate, it produce a turning effect from this point. The door tries to move from this point as we are applying the force from here. So the door is moving like this. This is the turning tendency of that force which we are applying. This is the turning tendency of force about which this is the point we are talking about this point where we want to generate the moment. We are trying to generate the moment. So moment of force is the turning tendency of that force about the point where we want to generate the moment. So basically the moment of force is dependent upon the this length and the amount of force we are applying. So it is given by moment is the product of force into perpendicular distance. So you can assume if this is the door, suppose it is hinged from here. Now I am applying the force here. So it is easily moving now. The door is easily moving. Now I am reducing this distance of applying my force. Now I am applying the force from here. So we will be requiring more magnitude of force to move this door now. Now I am reducing the distance more. We will be requiring more magnitude of force to rotate the door now, produce the turning effect. So this moment which we are talking about is dependent upon the perpendicular distance of the from where the force is been applied. This is the perpendicular distance with the force. So suppose this is the lever arm we are talking about. Now we want to produce a moment at this point. Suppose this point is x here. Now when I am applying the force from here, so this will try to move in this direction. Okay, now it will be as it is hinged from here, so it will not move from here, so it will rotate like this. Now this moment which we are producing at x, so this moment will depend upon this length and this magnitude of force. So moment of that force is given by force into perpendicular distance. Okay, so I hope this point is clear that the what is moment of a force. Basically you can also write in other term that it is the product of force and perpendicular distance, but in other words you can understand it by it is the turning tendency of the force, turning tendency of the force. So now this moment can be clockwise and anti-clockwise depending upon the situation. If we are applying force here, so this is producing a moment like this. Okay, this is producing a moment like this is anti-clockwise direction. If we are applying the force in this direction, now it will produce a moment in clockwise direction. So it is depending upon the situation. So it can be anti-clockwise and clockwise. So in you can see this is the force we are applying in this direction, so moment produced will be anti-clockwise. So this is the force and it is rotating anti-clockwise. If we are applying the force in that, it will rotate like this, that will be clockwise. So what will be the unit of movement? Unit will be simple, that it is the product of force and perpendicular distance. So what is the unit of force? So unit of force will be Newton and distance unit is in meters. So Newton meter is the SI unit of the moment. Okay, now what is point x here? We are talking about x. The point x is the moment center, moment center where we are producing the moment. So what is L? L is the movement arm. This is the movement arm or lever arm you can say, or where at which we are producing the moment. This is the movement arm. Okay, the action of movement, next point says that action of movement depends to cause a rotational motion of a body. So this movement will rotate the body. that will produce a rotational motion of the body. Okay, change in position of the body with respect to time is called motion. So what here we are talking about motion. What is motion? The change in position, when the position of any body changes with respect to time is known as motion. And motion are of two types, that are, you can say, translational motion and rotational motion. So translational motion are basically of two types, that is rectilinear motion and curvilinear motion. So here we will see what is translatory motion. Translatory motion is the motion in which all points of a moving body moves uniformly in the same line or direction is called translatory motion. So when the motion, suppose this is the car is moving in this direction. So all the points from where the car has gone, so that has created any path. So that path which has been created by the moving object, that is the uniform path, either it is in line or it is having certain specific direction. So that type of motion is known as translatory motion. Now translatory motion is of two types, one is rectilinear motion and one is curvilinear motion. So what is rectilinear motion? You can understand easily that when the motion is in straight line, when the path traveled by the object is in straight line, that type of motion is known as rectilinear motion. And when we it makes a curve, suppose this car is moving, rotating now, it there is a curve on the road and the car is turning like this. Now this type of motion is known as curvilinear motion. So rectilinear motion, if the motion is in the straight line, then it is called rectilinear motion. For example, train is moving. Okay, now curvilinear motion, if the motion is in the type of a curve, when the motion of any object is in type of a curve, then it is called curvilinear motion. For example, throwing of a stone form a curve, so that is curvilinear motion. As football, if you are hitting a football, it also make it goes like this, so that is curvilinear motion. Now next type of motion is rotational motion. So change in the orientation of the body, when the orientation of the body is changing, that type of motion is known as rotational motion. Next type of motion is vibratory motion. So that you must have seen in springs, that when you try to press this spring and leave the spring, so it tries to vibrate the spring. So that type of motion is known as vibratory motion, that is seen in springs. Okay, so when we are talking about movement, so if there is an body that is applied by um, more than two or three, there can be any number of moments that are being applied, so we need to calculate the resultant moment. So for that, if number of moments acts on the body, then the resultant moment will be the algebraic sum of all the moments. So we need to calculate the moment and it should be the algebraic sum. If it is in other direction, you need to minus that part. If two moments are in clockwise direction and one is in anti-clockwise direction, then you need to add both the moments which are in same direction and minus that moment which is in opposite direction. Suppose the resultant force will be algebraic sum. For example, um, if this is, we are talking about of this object, when we are to calculate the moment at O, suppose this is one force acting here, one force is acting here one force is acting here, and one force is acting here. Now how you will calculate the moment? So when this force will produce a moment. When we are talking at point O, we need to calculate the resultant moment at point O. And suppose this length is L1, this is L2, this is L3, and this is L4. Okay, now this is, if it is F1, it is F2, it is F3, it is F4. Okay, now moment at O with this force will try to move an object like this. So this type of motion is anti-clockwise direction. So this is anti-clockwise and this is producing clockwise moment. Okay, here you can see this F4 is producing clockwise and this is anti-clockwise. So both the clockwise will be added and the anti-clockwise will be minus, or you can add both the anti-clockwise and minus the clockwise. That depends upon you. If the resultant moment answer is coming different, if it is coming negative, that means the direction of that moment will be dependent upon the direction you have assumed. Okay, for example, if this is resultant force m1, this is the summation of all the algebraic sum of all the rings, but the direction is also considered here. So first will be F1 L1 will be the moment we are talking. Here I have taken different notation, but here I have taken different. So you can see if F1 with L1, this is producing clockwise, then clockwise is positive, and F3 is positive clockwise, then it is also positive, and other two are negative. So this is how you need to calculate the moment when there are number of moments acting at the body. Okay, now suppose this is a numerical that says that you need to calculate the moment at point O, where this is 2 meter and this is 3 meter. One force is acting at 5 meter away from this point, that is 2 kilonewton, and one force is acting 2 meter away in opposite direction, or 2 kilonewton. Now how will you calculate the moment at O? Now we need to calculate the moment at point O. For that I have told you that suppose now you have to see the lever arm from here to here, and one force is acting here, that is of 2 kilonewton, that will produce a moment of it is in anti-clockwise direction. So now you can make here that I am assuming the anti-clockwise moment as positive and clockwise moment as negative. Now you can assume that. Okay, now anti-clockwise moment will be force, that is force into perpendicular distance, and force is applied in this direction, perpendicular distance will be 2 plus 3, that will be 5. Okay, now the other force will produce a moment in clockwise direction, that will be minus, that will be 2 times into perpendicular distance will reduce to 2 now. Now for this force the moment at point O will be force into perpendicular distance. Now distance will be 2 meter for this force. So it will be 10 minus 4, that will be 6 kilonewton meter. Okay. So this is coming out to be 10 minus 4, that is positive. That means positive, as 10 minus 4 is 6. So this is positive and you have taken positive as anti-clockwise. That this positive means this resultant moment is in anti-clockwise direction. Okay, anti-clockwise direction. So resultant moment will be acting in anti-clockwise direction. You can see the other thing that here for calculating the moment at this point, now I have assumed the clockwise moment as positive and the anti-clockwise moment as negative. Okay, for that you can see, if I will you can write down here that if I have assumed opposite direction, that clockwise is positive and anti-clockwise will be negative. Okay, in that case, now see, this is 2 kilonewton and we need to calculate the moment at point O. Now it is producing an anti-clockwise moment. Now I have assumed the anti-clockwise moment, that is will be minus, because I have taken anti-clockwise negative. 2 into perpendicular distance will be 2 meter plus 3, that will be 5. Okay, now other is producing clockwise direction, that will be plus. Okay, that is 2 into 2. Okay, now this will come out to be minus 10 plus 4, that is minus 6 kilonewton meter. Now it is coming negative. Negative sign shows that the resultant moment will be in anti-clockwise direction. So here also anti-clockwise, here also anti-clockwise. So direction you can assume by yourself, and the answer will itself indicate if it is coming positive, then the direction will be positive of that you have assumed. If you have assumed clockwise positive, then the resultant moment will be also in clockwise direction. If you are assume the anti-clockwise direction as positive and your answer is coming out to be positive, in that case then the resultant moment will be in anti-clockwise direction. So it depends upon you. So what is the graphical representation of moment here? So graphical representation of moment will be moment of a force about point O. Suppose we are talking about moment about point O here, and one force has been applied in this direction. That is, force is applied along AB. So A, this is an object AB. So when we are talking about moment about point O, so we need to produce an perpendicular at that arm where the force has been applied. Suppose the force is in direction and we are calculating the moment about this point. So you need to drop a perpendicular at this arm, lever arm, where the force is being applied. Now this perpendicular distance from that point will be perpendicular to this force. So this will be force into perpendicular distance. In that case, moment will be AB into OP. This force is equal to AB. Okay, perpendicular distance equal to OP. So moment will be AB into OP, force into perpendicular distance. Okay, now suppose you are multiplying and dividing the term by 2 here. I have multiplied by 2 here, divided by 2. So half AB into OP will be AB into OP will be the area of this triangle OAB. So area of triangle OAB. Okay, the moment of force um, about a point is equal to the moment of a force about a point. You can say this is the force, and moment of this force about a point is equal to twice the area of a triangle, considering the axis of rotation as the vertices, and line of representing force as the base of the triangle. Line of representing force, this is the line which is representing the force as the base of the triangle. So moment can be defined as the moment of force about a point is equal to twice the area of a triangle, axis of rotation as the vertices of the triangle, and line of representing the force at the base of that triangle. Okay, so this is all about the moment of force.